Imagine you could step into a machine that takes you to the past or future. What would you do? Would you change history? Would you see the future? But wait, if you change something in the past, what happens to the present? Welcome to the fascinating world of time travel paradoxes. Time travel is the idea that we can move forward or backward in time just like we move through space. Sounds cool, right? But how does it work? Well, science says it might be possible under special conditions. Time travel has fascinated humans for centuries. The idea of moving through time, either to relive the past or glimpse of the future, has been a central theme in books, movies, and scientific discussions. The mystery of what would happen if we altered events keep people curious. Time travel can be divided into three main ideas. The first is traveling to the future. Scientists have discovered that the faster you move, the slower time passes for you compared to someone standing still. This means that if you travel near the speed of light, time will pass much slower for you than for those left behind. Astronauts in space experience this on a tiny scale, aging slightly less than people on Earth. This form of time travel is actually supported by Einstein's theory of relativity and has been tested with precise atomic clocks. The second concept is traveling to the past. Unlike future travel, moving back in time is much trickier. Some theorists suggest that wormholes, or hypothetical tunnels connecting two points in space time, might make backward time travel possible. However, no one has ever found or created a stable wormhole. Another possibility involves cosmic strings, which are energy filled structures stretching across space. Scientists speculate that if two of these strings were to pass each other at incredibly high speeds, they could bend space time in such a way that it might allow someone to travel back in time. The third idea involves parallel universes. Some theorists suggest that if you were to change an event in the past, instead of altering your own timeline, you might create a new one, separate universe where history unfolds differently. This means that every action taken in the past might lead to an entirely new reality, leaving your original timeline unaffected. If this is true, time travelers wouldn't have to worry about erasing themselves from existence. They would simply create an alternate world where their changes took effect. The grandfather paradox: can you change the past? We dream of leaping forward to witness the future, of stepping back to alter the past. But if time travel were possible, could we truly change history? Or would reality snap back, preventing us from rewriting destiny? One of the most mind bending dilemmas in this debate is known as the grandfather paradox. Imagine you travel back to the early 1900s to meet your grandfather before he had children. Curious and thrilled, you observe his life. But then a terrible accident occurs, or worse, an intentional action on your part prevents him from having children. If your grandfather never fathers your parent, then you are never born. And if you were never born, how could you have traveled back in time in the first place? This is the grandfather paradox, a contradiction that has puzzled physicists and philosophers alike. It suggests that changing the past could create a logical inconsistency, an event that erases the very conditions that allowed it to happen. So, if time travel were possible, does this paradox mean that the past is immutable? Are we bound by an unbreakable chain of events? Or does the universe have hidden mechanism to prevent such contradictions? One way to resolve the paradox is through the many world interpretation proposed in quantum mechanics. This theory suggests that every time an event could have multiple outcomes, the universe split into separate timelines. In one reality, your grandfather has children, and in another, he doesn't. This means that when you travel back and change history, you don't alter your own past, you simply create a new timeline where your changes take effect. Your original timeline remains intact, untouched by your meddling. This avoids the paradox entirely, but it raises another question. If every change creates a new branch, does that mean infinite versions of reality exist, each slightly different from the next? Another way to resolve the paradox is through the Novikov self-consistency principle, named after physicist Igor Novikov. This principle argues that time is self-correcting. Even if you have traveled to the past, events will always unfold in a way that prevents paradoxes. Under this principle, the universe would ensure that any attempt to change the past either fails or results in an event that paradoxically ensures the future remains unchanged. In other words, time travel may be possible, but free will in the past is not. The bootstrap paradox. Where did it come from? Time travel is a concept that has fascinated scientists and storytellers alike. It challenges our understanding of causality, free will, and the very fabric of reality. But what happens when an object, an idea, or even a person has no clear origin? What if something exists solely because time travel placed it there? This is the enigma of the bootstrap paradox. Unlike the grandfather paradox, which deals with the dangers of altering the past, the bootstrap paradox raises a different question. Can something exist without ever being created? Can information or an object be pulled from the future, sent into the past, and then retrieved again in the future, creating a self contained loop with no clear point of origin? Consider this: you are an aspiring inventor, working tirelessly to create a revolutionary new device. One day, a mysterious stranger arrives at your doorstep with a completed blueprint for the very invention you were struggling to design. You study it, build the device, and years later you decide to travel back in time and deliver that same blueprint to your past self. The question is, who actually invented it? Let's take a more poetic example. Imagine you travel back in time with a book containing all of Shakespeare's plays. You give it to young Shakespeare before he has written a single word. He copies them, publishes them, and then takes credit for their brilliance. Centuries later, someone finds this book and takes it back in time, again giving it to Shakespeare. But where did the original play come from? Shakespeare didn't create them. He merely copied what was already written. The information exists in an endless loop, never having an actual point of origin. This is the essence of the bootstrap paradox. The bootstrap paradox fundamentally challenges the principle of causality, the idea that every effect has a cause. In these paradoxical loops, something exists without ever having been created. It is as if the universe allows an object or piece of information to be pulled out of thin air, existing purely because time travel placed it into the past. Some physicists argue that the paradox implies that time travel to the past is impossible because it contradicts the logical progression of events. Others believe that the laws of physics might allow for the closed time loops, where causality is preserved in a way we do not yet understand. Could the bootstrap paradox be more than just a thought experiment? Some physicists have speculated that even the universe itself might be a form of bootstrap paradox. What if the universe was created not from external cause but as a self-sustaining loop of existence? If time is not strictly linear, Could reality itself be trapped in a time loop? Parallel universes, the many worlds idea. Imagine standing at a crossroads facing a decision. You take one path, but what if another version of you took the other? What if, with every choice you make, a new universe branches off, creating an infinite web of parallel realities? This is the foundation of the many world interpretation, a radical theory that suggests the universe isn't alone, it's one of countless others. The many worlds interpretation originates from the quantum mechanics, the science of the very small. Proposed in 1957 by physicist Hugh Everett III, this theory suggests that every quantum event that has multiple possible outcomes actually leads to all outcomes happening but in separate branching universe. In one reality, you choose coffee, in another, tea, in yet another, you never even woke up this morning. This theory has introduced to solve a troubling mystery in quantum physics. What happens when a quantum system is observed? According to traditional interpretation, a system collapses into a single outcome. But many worlds suggest something much stranger, that all possible outcomes occur, each in its own separate reality. Perhaps the best known thought experiment demonstrating this is Schrodinger's cat. Imagine a cat inside a box with a vial of poison that has 50% chance of being released, depending on a quantum event. According to the traditional physics, until we open the box and observe the outcome, the cat is both alive and dead, a paradoxical superposition of the states. But in the many worlds interpretation, the paradox vanishes. Instead of the cat being in both states simultaneously, the universe split itself. In one reality where the cat survives, another where it perishes. You exist in one universe, unaware of the countless others that branched off. Now let's apply this to time travel. If many worlds is true, then traveling to the past wouldn't alter our timeline. Instead, it would create a branching universe, one where the past was changed but the original timeline remains intact. This would solve paradoxes like the grandfather paradox. If you traveled back and prevented your grandfather from meeting your grandmother, you wouldn't erase yourself. Instead, you would create a new universe where you were never born, while your original self remains unaffected in a separate reality. While many worlds is an elegant explanation of quantum mechanics, there is no direct evidence that parallel universes exist. Some scientists propose that cosmic background radiation, leftover heat from the Big Bang, may hold hints of interaction with other realities. Others suggest that quantum computers, which rely on the superposition of states, might one day provide proof of parallel computation across universes. But if these realities do exist, the implications are staggering. Every possibility, every choice, every moment of history happening in countless ways in countless worlds. You might be watching this video in one universe, while in another you never found it at all. If parallel universes exist, it forces us to rethink fate, free will, and identity. Are we the sum of our choices or just one of the infinite variation of ourselves? Could we ever interact with these other realities, or are they forever out of reach, hidden behind the quantum veil? Can we actually time travel? Time travel, the ultimate fantasy of science fiction. But could it ever be more than just fiction? Could the universe actually allow us to move through time, just as we move through space? And if so, what would be the consequences? Time is not as rigid as it seems. According to Einstein's theory of relativity, time and space are deeply intertwined. Gravity, the force that holds planet and stars together, can bend and stretch time itself. This means that time can slow down under strong gravitational fields, a phenomena known as time dilation. In theory, if you were to orbit a black hole at the right speed, time for you would pass much slower than for those on Earth. You could return after what felt like mere hours only to find centuries had passed back home. This is one form of forward time travel proven by physics and even observed in astronauts on the International Space Station whose clocks run slightly slower than ours on Earth. Traveling forward in time is one thing, but what about going backward? That's where things get tricky. Some theories suggest that wormholes, hypothetical tunnels through space-time, could act as shortcuts allowing us to jump between different points in time. Theoretically, if one end of a wormhole were placed near a strong gravitational field, time at that end would pass slower than the other. If you entered the slower end and emerged from the faster end, you could, in a sense, travel to the past. But would this actually work? That's where we hit some serious paradoxes. Time travel to the past creates logical contradictions. If you went back and changed something crucial like preventing your own birth, how could you have existed in the first place to make that change? This is the grandfather paradox, one of the many logical dilemmas that suggest backward time travel may be impossible. So, can we time travel? Forward travel is already a reality. Astronauts experience it on a small scale, and extreme scenarios like black holes orbit could amplify the effect. Backward travel, however, remains theoretical, filled with paradoxes and requiring technology far beyond our reach. Yet, physics is an ever evolving field. New discoveries in quantum mechanics, gravity, and space time could one day bring us closer to unlocking the secrets of time itself. Time travel is one of the most fascinating ideas in science. Whether it's paradoxes, alternate timelines, or futuristic technology, the mystery continues. We have explored the mind bending possibilities of time travel, the logical puzzles it presents, the paradoxes that makes us question reality, and the scientific theories that suggest time is far more complex than we once believed. From the grandfather paradox to the bootstrap paradox, we have seen how altering the past could create logical contradictions. The many world interpretations offers a possible escape, suggesting that every choice or change spawns a new reality. And while current science tells us that traveling to the future is theoretically possible through time dilation, going back to the past remains a puzzle that may never be solved. But one thing is certain, time travel will continue to inspire curiosity, scientific research, and creative storytelling for generations to come. Perhaps one day, advances in physics will bring us closer to unlocking the true nature of time. Until then, we can only wonder, is time an unchangeable force, or is it just waiting for us to figure out how to rewrite it? What do you think? Can we change the past, or is time unbreakable? Let us know in the comments, and don't forget to like, subscribe, and hit the bell icon for more cool science videos. See you next time on Unlocking Spacetime.